Welcome back, everybody. I hope everyone is doing well and is healthy. Since this is the first video lesson, I thought it'd be a good idea to go through some expectations. With each video, I'm going to attach class notes. You're going to fill out those class notes just like you would do in class. You'll follow along with the video, with the smartboard presentation. And then at the end, you have practice problems to do. You're going to submit those practice problems on Canvas. It's going to count as your classwork, your homework. That I'm going to use, that submission, I'm going to use count as attendance. So if you're not submitting anything, then I can't mark you as present, and I'll have to eventually email home and make sure that you're getting the videos and you're doing what you're supposed to be doing. Okay, I'm going to start this first. The first video lesson is going to be what we did on Wednesday. There were quite a few people absent, so I thought it would be a good idea to just go through the first lesson of trig and just make sure everyone is on the same page. So last unit we looked at similar triangles, and we noticed that if triangles are similar, their corresponding sides are always in the same ratio, and the ratio of the corresponding sides are always equal. This is going to extend into what we call trigonometric ratios, and that's specifically for right triangles. So if we take a look at these two triangles here, so triangle ABC, triangle DEF, we know they are similar because they have, well, a couple of ways. We have two angles that are congruent, a right angle and a 37-degree angle. We also have their sides that are in proportion. So we can see that there's a scale factor of 2, 4 to 8, 3 to 6, 5 to 10. Okay, we're going to go ahead and calculate the ratios of these specific sides. So we're going to look at triangle ABC first. So triangle BC has a length of 3, AB is a length of 4, AC is a length of 5. The first ratio we're asked to calculate is BC over AC. So the length of BC is 3, AC is 5, so 3/5, or that's 0.6. AB over AC is 4/5, or 0.8. And BC over AB is 3/4, or 0.75. Now when we look at the ratio of the bigger triangle, DEF, we're going to notice something that happens, and hopefully it would make sense. EF over DF is 6/10, or 0.6. DE over DF is 8/10, or 0.8. And EF over DE is 6/8, or 0.75. Notice that the ratios between these two triangles are the same. So the ratios of the sides wind up being the same. And it should make sense that they're equal because the triangles are similar. So we could say something like, since the two triangles are similar, their sides are in proportion. So since their sides are in proportion, the ratio of their sides are going to wind up being equal. Okay. Now, these ratios that we just took a look at, so if we just go back here, the ratios here, 0.6, 0.8, 0.75, or 3/5, 4/5, 3/4, those ratios actually have very special names in trigonometry. So because all right triangles are similar, that share an acute angle are similar, the ratio of the sides of a right triangle don't depend on the size of the right triangle, but only on one of the acute angles. So we could, dilate a triangle and make it really, really, really big or really small. The ratios of their sides are always going to be exactly the same. And these ratios are known as trigonometric ratios. We sometimes say trig ratios for short. And they are defined by their relative positions with respect to an angle. Now we like to label our sides in a triangle based on the angle that we're looking from, based from the perspective of a certain angle. So if we are looking at angle A, so say we're looking at it from the perspective of angle A, well, we're going to label our triangle with 3 words: adjacent, opposite, and hypotenuse. So the hypotenuse, that's always across from your right triangle. So always across from your right angle, I should say. The adjacent side is the one that makes the angle with the hypotenuse. So we're using angle A, so the adjacent side is the one that's right next to angle A. So that's right here. So side AB would be our adjacent. And the last side, the one that's completely opposite the angle we're using, is called our opposite. We're going to be using the adjacent, opposite, and hypotenuse to make ratios. So our first trig ratio we call sine, and we abbreviate it as just SIN. And that is the opposite of angle A, so side BC, over the hypotenuse, which is AC. So CB over AC. That's sine ratio. The cosine ratio is the adjacent side, so side AB, over the hypotenuse, AC. And the tangent ratio is opposite, BC, over adjacent, AB. So if we take a look backwards, we actually calculated sine, cosine, and tangent. We calculated the sine ratio, the cosine ratio, and the tangent ratio. If we go back here, kind of label this triangle real quick. This is opposite, this is adjacent, and this is the hypotenuse. So this column right here, BC over AC, BC over AC, let's see, BC is opposite, AC is hypotenuse, that's opposite side over the hypotenuse. We just calculated the sine ratio, SIN. This column, next column, AB over AC, that's adjacent over hypotenuse, and that's cosine. And this last column, BC over AB, that's opposite over adjacent. So we actually just calculated the tangent ratio. And you didn't even know it, but that's what we wound up doing. The calculator will actually calculate the ratios for you. You just want to make sure you're in degree mode on your calculator. But if we were to take a look at, say, a calculator, and we want to calculate the ratio of a triangle opposite over hypotenuse, we want to calculate the sine ratio of a 37-degree angle. We don't need to know how big the triangle is, because any 37-degree angle in a triangle will always have the same opposite over hypotenuse ratio. So if I did sine of 37 degrees, it's going to be about 0.6, which is what we found out over here. Okay, we found out the sine ratio was 0.6. If we were to do the cosine ratio, so if we did the cosine ratio of 37 degrees, we're going to see it's about 0.8, which is what we found. And then if we were to do the tangent ratio of 37 degrees, it's about 0.75, which is what we pretty much found out. So your calculator can calculate the ratios for you as long as you know the degree measure of the angle. Okay? So trigonometry is the branch of mathematics that studies the relationship between angles and sides. We use angles and sides, and then we could figure out ratios. Maybe we want to figure out the length of a side. Maybe we want to figure out the measure of an angle. We use trigonometry to figure that out. And we are always looking at the triangle from the perspective of a given angle. Sometimes we use this new variable. It's kind of just like a circle with a line through it. We call that symbol theta. Okay, it's just a Greek symbol. We call it theta. That's used sometimes instead of maybe a variable x, or sometimes you might just call it, angle A, looking at it from angle A, or, it doesn't matter. They're always looking at it from the perspective of an angle. In this case, we're looking at it from the perspective of this angle here. We're calling it theta, and we're asked to label our triangle with 3 words: opposite, adjacent, hypotenuse. So we just did that a moment ago. If you remember, the hypotenuse is probably the easiest one. The hypotenuse is always across from your right angle. That's your hypotenuse. The next one that we'll take a look at is the adjacent side. The adjacent side is the one that makes the angle with the hypotenuse. So our adjacent side is right next to our angle that we're using. That's over here. And then the opposite side is opposite our angle, and that's over here. So we always want to label it with those 3 words, so this way we can set up our correct trig ratio. So why don't you take a moment, pause the video, and go ahead and label your sides from the perspective of the given angle. I'll just do maybe the first one with you, and then I'll let you pause it. So we're looking at it from this angle here. I always start with the hypotenuse first. The hypotenuse is crossed from the right angle. My adjacent side, okay, that's the one that's next to the angle. And then my opposite side is completely opposite the angle. Why don't you take a moment, pause the video, and go ahead and do those next 5 problems. So here are the answers that you should have gotten. Okay. So again, just we are going to look specifically at these 3 ratios. So sine, cosine, and tangent. Sine is the ratio of the opposite side over the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You'll hear the phrase SOHCAHTOA. SOHCAHTOA is a way to remember these ratios. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. It's just a nice way to remember sine, cosine, and tangent. So if we look at exercise number 3, it's asking us to give the correct trig ratio. So the first thing we're going to do is label our triangle with opposite, adjacent, hypotenuse. We need to realize what angle we're working from. So they're telling us sine, cosine, and tangent of angle R. So we are working from angle R. So I'm just going to kind of do that there. And now I can go ahead and start labeling with opposite, adjacent, hypotenuse. So 13, that's my hypotenuse. It's the longest side. It's also across from the right angle. 12 is the adjacent side. And 5 is the opposite side. So sine of angle R, sine again is opposite over hypotenuse. So opposite is 5. Hypotenuse is 13, and that's it. We're going to leave it as a fraction, as a ratio. Cosine of angle R, cosine is adjacent over hypotenuse. So our adjacent side is 12. The hypotenuse is 13. So our ratio is 12/13. And tangent, tan is opposite over adjacent. So tangent is opposite side is 5. The adjacent side is 12. Now, D, E, and F, well, they're now saying sine, cosine, and tangent of a different angle, angle T. So that changes some things. What's going to happen is we are now looking at it from angle T. So since we look at it from angle T, some of our sides need to be labeled differently. Now 5 is the adjacent side and 12 is the opposite side. Okay. So sine of angle T, sine is still opposite over hypotenuse, but this time since we're looking at it from the perspective of angle T, the opposite is 12. The hypotenuse is still 13. Cosine, again, is still the same. It's still adjacent over hypotenuse. The adjacent side is now 5, and the hypotenuse is 13. And tangent is once again still opposite over adjacent, but the opposite now is 12, and the adjacent side is 5. So again, important to know what angle you're looking at it from. This next example, they don't give us a diagram. Sometimes we have to draw it out ourselves, which is fine. We'll draw ourselves a right triangle. So in triangle MNP, P is a right angle. So I know P has to go here. M and N don't matter. I can put M up here or M down here. It doesn't matter. Just commit to one of them. MP is 24. NP is 10, and MN is 26. Which of the following is the correct value of cosine of n? So we're looking at it from angle n. So let's label the triangle. Here's our hypotenuse. This is the adjacent, and this is our opposite. Since we're dealing with cosine, cosine is SOHCAHTOA, so adjacent over hypotenuse. So cosine of angle N is the adjacent side over the hypotenuse side. The adjacent side is 10. The hypotenuse side is 26. It's not a choice, but we'll find the equivalent choice. That reduces down to 5/13. Right, we'll take a look at another one. So once again, we have a right triangle. It's not labeled for us, so we'll just draw our own, no big deal. Angle C is the one that's 90 degrees, so let's just make this A and this one B. AB is 5, AC is 4. Which statement is not true? Okay, we're missing a side. So if we're missing a side, think about it, we have a right triangle. We have 2 out of the 3 sides. If we're missing a side, we would go ahead and use the Pythagorean theorem, a squared plus b squared equals c squared. 4 is one of the legs. We need to find the other leg, and 5 is the hypotenuse. So just solving this through, we get x squared equals 9. So x equals plus or minus 3, but we're dealing with side length, so we're just going to take the positive. If you knew it was a 3, 4, 5 right triangle, totally fine. You could just, you don't have to do that work. So now we have it completely labeled. We want to know which statement is not true. We have to just go through our choices. So cosine of, we have kind of 2 things going on here. We have choices 1 and 2 are looking at it from the perspective of angle A. Choices 3 and 4 are looking at it from the perspective of angle B. So let's start with choices 1 and 2 and see how they are. So cosine of angle A. So if I'm here, cosine of angle A, okay, so let's label it. This is the hypotenuse, this is the adjacent, and this is the opposite. So cosine, that means 4 needs to be the adjacent and 5 needs to be the hypotenuse. 4 is the adjacent, 5 is the hypotenuse. That is true. Let's look back at the, let's look at the next one. Tan of A. So that means 3 needs to be the opposite and 4 needs to be the adjacent. 3 is opposite, 4 is the adjacent. That's true. Okay, so that works. So let's kind of erase all this. Let's erase this. Okay, now let's take a look at it from the perspective of angle B. So now since we're looking at it from angle B, all right, 5 is still the hypotenuse. And now 4 is the opposite, 3 is the adjacent. So let's go through these. Sine of B. 4 needs to be opposite, 5 needs to be hypotenuse. 4 opposite, 5 hypotenuse, that one's good. So this one must be incorrect. 5 needs to be the opposite, 3 needs to be the adjacent. That's not the case. In order for this to be correct, tan of B would need to be opposite over adjacent, 4/3. So our answer is choice 4. This one here is pretty tricky, and we need to take into account that they're telling us that these 2 triangles are similar. Since they're similar, their corresponding angles are congruent. So angle E we know is congruent to angle J. Angle R we know is going to be congruent to angle T. And then these 2 are both congruent because they're both right angles. So when we have similar triangles, that means their sine, cosine, and tangent ratios will be the same. So the cosine of angle J is going to equal the same as the cosine of angle E. The cosine of angle R, since angle R and angle T are both congruent and they're both in right triangles, so the cosine of angle R is going to be equal and equivalent to the cosine of angle T. Tan of angle T is going to also, should be the same or will be the same as the tan of angle R, and tan of angle E is going to be equal to tan of angle J. So we need to really be looking at 2 different ratios because we have 2 angles that are congruent. So cosine of J and cosine of E are equal, cosine of R, cosine of T are equal, tan of T, tan of R, and then tan of E and tan of J are equal. So if in the first one, if one of these, if either cosine of J or cosine of E equals Rm over Re, then it's a true statement. If cosine of r or cosine of t equals jm over jt, then it's a true statement. Tan of t, tan of r, if that equals that, then it's a true statement. And then finally, tan of e or tan of j. If tan of e or tan of j equals tm over jm, then it's a true statement. Take a moment and go through and see if you could figure out which is always true. So pause the video and take a look. So it should be, the right answer is choice 4. While tan of e is opposite over adjacent, so opposite, here's e, here's adjacent, so tan of e is rm over me. Well, wait a second, that's not tm over jm. But remember, tan of e and tan of j are equal. So we can kind of swap their sides. There'll be the same ratio. Tan of j is opposite, so tm over adjacent, which is jm. So since tan of j equals tm over jm, tan of e also has to have that same ratio. So that's why it is choice 4. If you go through these choices 1, 2, and 3, you're not going to find that either of those work. And then finally, we have our last question here. Which ratio is always equivalent to sine of angle A? We notice here we have 2 triangles, and they happen to be similar triangles. They're similar because they both share angle A, and BC and DE are parallel, so you have some corresponding angles going on there. So they're going to be similar by angle. We have 2 triangles that are similar, ACB and AED. Whoa, that was not good. And all right, there we go. I'm gonna try my best. Okay, so sine of angle A. Sine, again, is opposite over hypotenuse. Since we have 2 triangles, we can make 2 ratios. In the yellow triangle, the opposite is BC, and the hypotenuse is AB. So that's one possibility. In the bigger triangle, so the light blue one, the opposite is DE, and the hypotenuse is AD. So either of these 2 could be a correct ratio. We just have to take a look, and it is choice 3. Okay. So you do have some practice, classwork, homework, whatever you want to call it, that you need to submit. You need to submit that by 5 p.m. This way that I can look it over, give you feedback, and give you attendance credit for the class. If you have any questions at all, you could always email me. You could post on the message board, and hopefully either myself or another classmate could answer you. Okay? All right, I hope you guys have a good rest of your day.